Hi everyone, today we're presenting our project for the visualization track, where we visualized biological and behavioral patterns in HDL cholesterol. My name is Jacci,
And I'm Arya.
and we were assisted in this project by my teacher from Ransom Everglades, Miss Hinkelari.
So our project explores patterns in HDL cholesterol using data from the NHANES Health Survey data. HDL essentially helps protect against heart disease by removing harmful LDL cholesterol from the bloodstream and transporting it away from the arteries. We wanted to understand how the variation in HDL levels can provide insight into cardiovascular health and also show us different risk factors.
When we approached this project, we followed four main steps. First, we kind of performed this exploratory visualization to understand the structure of our overall larger data set. This included histograms, box plots, scatter plots, normal QQ plots, and these were meant to evaluate distributions, variability, and potential outliers. Next, we selected this meaningful story within the data. We chose to focus on, again, behavioral versus biological aspects, and we focused specifically more on alcohol intake and sex. We then conducted group comparisons. We used box plots and scatter plots to examine differences across our sex and alcohol intake groups. We also kind of chose to run other statistical tests to kind of verify and analyze deeper. We ran ANOVA, Kruskal-Wallis, etc. And finally, we explored predictor importance and we identified key variables associated with HDL.
Okay, we started off by looking at the relationship between sex and HDL cholesterol levels. The box plot, as shown, shows the difference in HDL by sex. And you can see clearly that the entire female distribution is shifted upward relative to the male distribution. Specifically, the median HDL level for females is approximately 58.6 milligrams per deciliter, while the median for males is about 49 milligrams per deciliter. This shows a difference of about 10 milligrams per deciliter. And because this variability between both of the groups were similar, this shows a rather systematic shift across the distribution rather than the presence of extreme values having too much of an effect on the distribution.
Yeah, so next we examined whether alcohol consumption is associated with HDL levels. When we first started off, we were able to examine a weak but positive relationship with a correlation coefficient of approximately 0.17. Now, this seems like relatively low. However, amongst all the other behavioral variables, this was the second highest that we found. The scatter plot that we chose shows how HDL levels are compared to alcohol intake for individuals in our data set. Each point on the scatter plot, as you can clearly see, it represents an observation, and the colors indicate different alcohol consumption groups. So, as we can see from this visualization, we can see how HDL levels kind of tend to increase from non drinkers to drinkers, with a little like balance out with the moderate drinkers. And we can see this positive relationship that I mentioned before. However, we also do see that these HDL values slightly decline amongst individuals with very high kind of alcohol intake. And this indicates that the relationship may or may not be strictly linear.
For our key takeaways, we noted that biological factors do appear to have the strongest influence on HDL levels. The consistent shift in HDL distributions between males and females shows that sex plays a major role in shaping the regulation of HDL. Secondary, the behavioral factors such as alcohol consumption do contribute to additional variation, but they're not really determining factors when we look at HDL levels as a whole. We can see that moderate alcohol intake is associated with higher HDL. The widespread of the data shows that there are many more variables that influence cholesterol levels to a higher degree.
Yeah, so taken together, these results that we see suggest that HDL levels reflect both like biological structure and lifestyle behaviors. However, we do see that biological factors kind of appear to have a stronger organizing influence in this data set. Understanding how these factors interact can help improve our interpretations of cardiovascular risk and guide further health research. Thank you for listening.